So in this video, we're going to see how we can solve a cubic equation. So we're going to learn how Cardano solved cubic equations. Before we begin, I would like to first remind you of the Babylonian method for solving quadratic equations, because we're going to need that here. So let's say we wanted to solve a problem where we know that the sum of two numbers, x and y, is 14, and the product of two numbers, x and y, is 48. So remember that alpha is going to be the average of those two numbers. So that would be x plus y divided by 2. Delta is the deviation, meaning how far are x and y away from the average of the two numbers. And then there was a formula that alpha squared minus x times y is delta squared. And remember that we had a geometric derivation for this formula. So now let's go through the steps. So how would we find x and y? First, what's the average? It's the sum divided by 2. So 14 over 2 is 7. We square that number. So 7 squared is 49. And then we calculate alpha squared minus xy. Xy is the product. So we take 49, which is alpha squared, minus the product, which is 48. So 49 minus 48 is 1. But alpha squared minus xy is delta squared. So that means delta squared must equal 1. And therefore, delta is just 1. And then, once you know what alpha and delta are, then x is alpha plus delta, so we get 8. And y is alpha minus delta, and so we get 6. And then we can check our answers. So what is x plus y? That's 8 plus 6 is 14. Yes, that's what we were hoping for. And x times y is 8 times 6, which is 48. And that's what we were hoping for. So now with that in mind, let's begin solving cubic equations. So here's our first example. We want to solve the equation x cubed minus 24x, or x squared is equal to 24x plus 72. So if your cubic is in this form, here are the steps that you use to solve the equation. Step 1, replace x by s plus t. So x is equal to s plus t. Plug that into this equation. So we get s plus t cubed is 24 times s plus t plus 72. Now, if we expand the left-hand side using the binomial coefficients, we get that s plus t cubed is s cubed plus 3s squared t plus 3st cubed plus t cubed is equal to 24s plus t plus 72. Now, we actually don't bother expanding this out. It's because of a trick we're going to use. So what I want to do is I want to find an s plus t over here. Well, notice that if I just look at these terms right here, I can factor out a 3st And then that would be multiplied by S plus T. So now on the left side of the equation, I have something times S plus T. And on the right-hand side of the equation, I have something times S plus T. And so the next trick is to find a way to get rid of all of this. So we would like those two things to be equal to each other. How do we make that happen? Well, it would be nice if we had that 3ST is equal to 24. And so in order for that to be true, then we're going to choose that S times T is equal to 8. Let's plug that in. So the left-hand side becomes S cubed plus 24 times S plus T cubed. And then the right-hand side is 24S plus T plus 72. And then indeed, those two things are equal on both sides of the equality. And so we subtract that from both sides. And then we get simply S cubed plus T cubed is equal to 72. So that is our trick. The next step is, let's set this up as a sum and product problem. So remember, we just had S cubed plus T cubed is 72. So that's what I wrote down here. But what is S cubed times T cubed? Well, I don't know what that is, but I know what ST is. So S cubed times T cubed is just ST cubed. But what is ST? ST we decided, or we chose to be 8. So ST cubed is 8 cubed, and that's just 512. Now we're going to make yet another substitution. So here we have the product of two numbers is 72, where the first number is S cubed and the second number is T cubed. So S cubed will be U and T cubed will be V. And then what is U times V? It's U times V is 512. So U times V is 512. When we make that substitution, and the substitution being that U is S cubed and V is T cubed. So now we have a sum and product problem. So here it is. The sum of two numbers is 72. The product of those same two numbers is 512. So alpha, remember, was the average of those two numbers, which is the sum divided by 2. The sum was 72. Divided by 2 is 36. Next, alpha squared is 36 squared. Now, in the absence of calculators, it would have been pretty typical to have tables of squares, and that would help in doing problems more quickly. And so, for example, what is 36 squared? Well, here's the 30s. And so here's our 36 squared. I'm just going to copy that over from the table. Then I'm going to calculate alpha squared minus the product. So it's 1296 minus the product, and the product, remember, was 512. And we get 784. And remember that alpha squared minus the product is delta squared. So delta squared is 784. And then we go back to our table of squares to see that 784 is 28 squared. So now we know what alpha and delta are. And so the first number, u, is alpha plus delta, which is 64. The second number, v, is alpha minus delta, which is 8. So now we know what u and v are, and then we just need to substitute back to find out what s and t are, and then we need to use that to find x. So step 5 is to find s and t. Well, remember that u was s cubed, but also u we calculated to be 64. And so that means that since s cubed is 64, then s is equal to 4. Similarly, t cubed was what we were calling v, and we figured out that that was 8. So since t cubed is 8, then t must be 2. And then finally, what's x? Remember, we started by making the substitution x is s plus t. And so that would be 4 plus 2, which is 6. And then we can check our work. So is it true that when we plug in x is equal to 6, that it satisfies this equation? So 6 cubed is 216. 24 times 6 is 144. And then we just have that 72. So is 216 equal to 144 plus 72? Well, yes, it is. And so our answer checks out. So now I'd like to work out one more example, and I'm just going to work this example out live. And then finally, what we're going to do is see whether we can use this process to figure out a formula for the solution to such an equation. So just like we have the quadratic formula for finding solutions to quadratic equations, we can find a similar formula for cubic equations of this type. So here is our next example. So the first thing that we need to do is we want to set x equal to s plus t. We're going to substitute that into our equation. And then we know that when we substitute it into this side, that we're going to want to have that s plus t factored out. So what I'm going to get is that s cubed plus 3st times s plus t. So this is just like we did before. Plus t cubed is equal to 9 times s plus t plus 28. And then in this case, let's take a look. We want 3st to be equal to 9, and therefore we want st to be equal to 3, so that those two are equal, so that 3 times st is equal to 9. And so now when we make that substitution, that st is equal to 3, what we're going to get is that this term and this term will cancel each other out. And so that leaves us with s cubed plus t cubed is equal to 28. And also, since we know that we're going to need it, let's go ahead and calculate s cubed times t cubed. Well, that's st cubed And st was 3, so that's 3 cubed. So we get 27. So now what we're going to do is we're going to set u is equal to s cubed. We're going to set v is equal to t cubed. And so now what we have is that u plus v is equal to 28. That was from that. And then we're going to get u times v is equal to 27. And that was from that. So now let's go ahead and use the Babylonian method to solve this. So we're going to get alpha is going to be u plus v, which is 28 divided by 2, so that's 14. Alpha squared, well, we can go ahead and look at our table of squares, and we see that we get 196. Now let's go ahead and do alpha squared minus uv. And so that's going to be 196 minus, and then uv was 27, and that's just 169. And so that's what our delta squared is. So what's delta? It's going to be the square root of 169. So that's on our table of squares right there. And we see that that's going to be 13 squared. So delta is 13. Okay, so let's see what we have. So we have from the previous page, what is alpha? Alpha is 14. What is delta? Delta is 13. And so our two answers are u is equal to alpha plus delta. So that's 27. And that was our s cubed. What's v? That's going to be alpha minus delta. And alpha minus delta is 1, and that is our t cubed. So from this we get, so s is equal to the cube root of 27. So that's 3. T is equal to the cube root of 1. So that's 1. So what's x? Well, that was s plus t. So that's going to be 3 plus 1, which is 4. And then we can go ahead and check our work. So the equation was that x cubed is equal to 9x plus 28. So 4 cubed is going to be 64. And then 9 times x is going to be 36 plus 28. And is that true? Yes. So it looks like we solved it correctly. So now finally, what I'd like to do is look to see how we can take this method and generate a general formula for solving equations of this type. So let's say that we have a general equation. X cubed is something times x plus something. So instead of having fixed numbers like we had in the previous example, we're going to just assume that these are arbitrary. But we're going to follow all of the same steps. So we're going to begin by substituting x is equal to s plus t. So s plus t cubed is p times s plus t plus q. And then on the left-hand side, we do the usual thing, s cubed plus 3st times s plus t plus t cubed. And then the right-hand side, we leave it as is. Then, because we want 3st to be equal to p, that's what I wrote here, then st must be, we'll just divide both sides by 3 to get st is p over 3. And then that's going to cause these terms to drop out. And so after we make that substitution, and these terms drop out, what we're left with is s cubed plus t cubed is equal to just q. And then once again, we need to figure out what s cubed times t cubed is. So s cubed times t cubed is s times t cubed. But what was s times t? Well, we said it was p over 3. So we get p over 3 cubed. Okay, so copying over from the previous page, we have that s cubed plus t cubed is equal to q, and then s cubed times t cubed is st cubed, which is p over 3 cubed. And then we're going to go ahead and make this substitution. U is s cubed and v is t cubed. So now let's go ahead and do our Babylonian method. We get alpha is equal to the sum, and the sum of u and v is q. Divide that in half. Then alpha squared, just square that number. Then take alpha squared minus the product, and here's the product. So alpha squared is q over 2 squared minus the product, which is p over 3 cubed. So therefore, delta squared is this number. And so to find delta, you have to take the square root of that number. Now let's go ahead and find u and v. So u is alpha plus delta. So alpha was q over 2. And then delta was this whole square root thing. So we get q over 2 plus the square root of q over 2 squared minus p over 3 cubed. And then v is alpha minus delta, which is alpha, which is q over 2, minus delta, which is the square root of q over 2 squared minus p over 3 cubed. Now, remember that u was s cubed and v was t cubed. So we need to take the cube root of u and v to get s and t. So the cube root of this will be s. The cube root of this will be t. And then we add those two numbers together to get x. And then that gives us this formula that x is equal to the cube root of the first number plus the cube root of the second number. So cube root of q over 2 plus square root of q over 2 squared minus p over 3 cubed plus the cube root of q over 2 minus the square root of q over 2 squared minus p over 3 cubed. And this is known as Cardano's formula for solving cubic equations.